well, maybe this is a good time to get started. Thank you all for joining us for this webinar about existing and emerging metadata efforts with respect to physical samples. Kirsten, did you want to say a word of welcome?
Yeah, just wanted to welcome everybody. As Megan said, great turnout. I think this is a really good and important effort to bring these different perspectives of physical sample metadata efforts together. We're doing this in preparation of a workshop that's going to happen in about 2 weeks in LA, and we know that not everybody can participate in the workshop, so this is a great way of getting everybody involved in the preparations, and we expect to hold another webinar after the workshop to report on outcomes of the discussions. With that, I don't want to take any other time and give the stage to Jens and start talking about the IGSN schema for CSIRO allocating agent.
So I just wanted to mention briefly before we start, each of these speakers will speak for roughly 10 minutes, and then we hope to have a bit of time afterwards for questions and discussion. This webinar will also be made available for future viewing, and I will be in touch about how to do that. So Jens, I will now pass you the screen share.
Okay. So can everybody see the screen now with a nice landscape and a lot of blue?
Jens, we cannot actually see your screen. Did you click Share Application under Quick Start?
Where do I need to click Share Application?
So at the top, there's Meeting Info and Quick Start. If you go to Quick Start, then you will see a box at the bottom that says Share Application.
Share Screen.
Yes, there we go.
Can you see it now?
Yes.
Okay. So I'll be brief, just to say a few words about why we are starting now. Because we were lucky in Australia to have resources to be made available to implement the IGSN for the geo community in Australia. CSIRO is a member of IGSN, and so are Geoscience Australia and Curtin University. And at CSIRO, we are now implementing the IGSN in several systems, starting with the repository of the Australian Resources Research Centre in Perth, then for the Capricorn Digital Footprints Project and for the Australian National Collection of Mineral Reflectance Spectra. And more collections will follow, which led to the interesting situation that the IT department suddenly said, oh, isn't this our job? So we have to make this into sustainable service. To be operated by our Department of Information Management and Technology, which is part of CSIRO's National Facilities and Collections. And as I mentioned earlier, CSIRO has joint projects with Geoscience Australia and Curtin University in Perth to implement IGSN for the Australian geoscience community. So as a reminder, what is the idea behind the different metadata schemas? Back in 2011 at the workshop in San Diego for IGSN, we decided to split metadata into the registration, as also called administrative metadata, and the description of the samples. So the basic idea was the client registers a sample with an allocating agent, transmitting administrative metadata and descriptive metadata. Then the agent registers the sample with IGSN, passing on the administrative metadata, so the IGSN registry does not hold any description. The allocating agent makes the detailed descriptions or more detailed descriptions available through an OAI PMH interface that can be harvested by communities of practice into metadata portals. Why did we do the separation of administrative and descriptive metadata? This is a learning from setting up DataCite, where we saw that if we run this as a common service for diverse communities, then we can have either a least common denominator, which is pretty poor in descriptive metadata, or we can try to design something all-encompassing, which then will have lots of optional elements to suit everybody, which will then result in most of those optional elements being empty. So neither of the two really serves the purpose, and that's where the decision came from, to have the communities of practice define their metadata, an extension of the core set of metadata. And my aim for the workshop in LA is to define that core set of metadata and then see how that can be extended by communities of practice. And just as a technical reminder, the OAI-PMH protocol is a protocol and not a profile. So people thinking that it can only transmit Darwin Core, this is not what the definition says. It is a protocol and it can transmit any profile. So what does the administrative metadata look like? This is the metadata elements we already use for IGSN registration. And the elements can be grouped into 4 groups: the sample number itself, the registrant, which has been identified, then the related identifier, which is a really interesting element because it points to a related object and describes the relation type, the nature of that relation between those two objects, and a log element to record changes to the registration or to the specimen over time. Also note that the URL of the landing page is not part of the metadata, but it is part of the web service call to register the IGSN. So for CSIRO, we looked at existing description schemas like the one used in geosamples.org, and we looked at models in Quasi ODM2, we looked at O&M, we looked at DataCite to see what are common elements that would help us describe our samples. And the 4 groups of elements we identified are sample identification, IGSN, field name, type, classification, then sampling activity describing where the sample came from and how it was obtained and by whom, then a block on sample curation telling about who is the current curator and where is it stored, and then a block on related resources, the related object and the relation type. This is for use within CSIRO, and here we united the administrative metadata with the descriptive metadata into one schema. So you see that there's some overlap with what I called administrative metadata a slide earlier. But those were the elements that we saw as common, and then anything else would be specific to sample, to specific sample types like water or rocks or plant materials or whatever. So what are the next steps and open questions? The CSIRO proposal for IGSN metadata is online at the URL given here, and we will mail this URL again. There you will also find more detailed documentation about the proposal, and this also points to the questions that we will want to discuss offline and at the workshop. So we want to define what is the scope of the core metadata set, not everything, but the core that everybody should fulfill. And so which metadata elements are useful and sufficient for this core description. What are the cardinalities of elements? So which ones must be populated and how can they be populated? And do we want to use controlled vocabularies? And if yes, where can we leverage existing controlled vocabularies? And just a technical note from IGSN side, we are in the process of consolidating the IGSN web resources, and this is still work in progress. So please excuse that documentation at the moment is scattered across different websites. So that's a brief introduction, and yeah, if there's any urgent question now, I think we can take that. Otherwise, I'll pass the screen back to the organizers.
Okay, great. Thank you, Jens. As Jens said, if there are any very pressing questions, you're welcome to ask them now, but I think it would be best if we could go through the 4 presentations and then have a little bit of time for questions or discussion.
Yeah, while you're switching, I just wanted to add on to what Jens said on the last slide about requirements for metadata, that this is going to become an issue when IGSNs are used in publications to ensure access to metadata for the samples. So we will have to think in the context of publishing requirements, what is necessary for a sample to be meaningfully described. We have so far had very little constraints on registrations. The completeness of metadata was basically left to the allocating agents and to the users, to the registrants. So this is going to be an important step for making the IGSN really a component of standards for publication.
Okay, so next we have Bob Arko, who's going to be talking about the EarthCube GeoLink Project, describing physical samples as linked data. So Bob, I will now pass you the screen share and unmute you.
Well, I think that actually worked. Folks are seeing this?
Mm-hmm.
Okay, good morning. I appreciate the opportunity. Just have half a dozen slides to say a few words about the GeoLink project that's underway as part of the EarthCube initiative in the U.S., funded by NSF, and the work we're doing relative to physical samples. Our goal is to facilitate discovery and access of data very broadly among geoscience repositories. So recognizing that it's still much too difficult to recognize, to find content between repositories and find relationships between content. So our work plan that started last fall and that will continue until next fall is to publish a simple set of ontology design patterns that describe things like field expeditions, sensor and sample data sets, lab analyses, publications, funding awards, the kind of things that are fundamental search terms for investigators looking for content. And then to work with a dozen or so different repositories funded by NSF to start publishing their content as linked data using those patterns, and then to put all that together in a shared knowledge base and test it against a couple science use cases. So the partners that are in GeoLink, almost all of them have data about physical specimens in one form or another. So it means that IGSNs are highly relevant for us. All of our design work follows the principles of linked data as it's been spelled out by the World Wide Web Consortium, which means that every resource has to have a network name, a URI that begins with HTTP. Every person, every organization, every specimen, every lab analysis, every data set, every field expedition needs to have a URI. And then we describe those things using a standard language called RDF. We implement a standard query language called Sparkle so that you can run queries over the web against that content. And then most importantly, each participating repository that publishes linked data should include links to content at other repositories. We've spent a significant amount of time in the first year devising the 24 or so classes that we believe characterize the fundamental concepts that you'd want to use as search terms in attempting to discover data between repositories. And the ones that would be relevant in the IGSN context would be, for example, data set, feature of interest, geologic age, physical sample, and repository. The modeling work we've done on geologic age and physical sample has been recent, just this past month, in fact. We had an in-person meeting at Woods Hole, spent a significant amount of time on physical samples, so it's quite timely that we have this workshop coming up in LA, where I'll be able to present a little more on our work in detail and get some feedback. We ended up coming up with on the order of 16 or so different properties to describe a physical sample. This was a very ground-up effort, I should say, from the grassroots upwards. So we looked at CSIRO, we looked at ocean drilling, we looked at BCO-DEMO, we looked at Data One, we looked at the partner repositories in GeoLink that already have content about physical samples and attempted to come up with the essential subset of properties that would allow them to start publishing their content right away. It boils down to an identifier, the ability to say that a sample is part of a data set, has a parent physical sample, has both a digital and a physical repository. We want to characterize the fact that a sample may have come from a cruise or a submersible dive, and probably also a land campaign. We need to record the collection time and the person who collected the sample, the feature of interest where it was collected, the position where it was collected as a simple geometry. And then it looks like maybe half a dozen or so pretty straightforward properties like tectonic settings, stratigraphic unit, geologic age, sampling method, and material type. So from our perspective, at least in the work we've done so far, that's the essential subset of properties you need to enable basic discovery between repositories. Second last slide. We spent a good deal of time grappling with identifiers. Obviously, that gets tricky. Our goal is to use globally unique identifiers wherever possible. So DOIs for data sets, ORCIDs for humans, ISNIs for organizations, and of course, IGSNs for samples. What we've decided to do is adopt the approach that DataCite has taken, where basically for every identifier, you provide both the scheme and the value. And that works out nicely because DataCite has a nice controlled vocabulary.
Awesome. Thanks, Emily.
Oops, I just got some echo. Do I still sound okay?
Yeah, I think it was just somebody not being muted. Just go.
Okay. Okay. DataCite has a nice controlled vocabulary of, I think it's about 20 or so different recognized identifier schemes, and everything we think we need is in that vocabulary. So we're simply going to use that. And that way, because it's not enough just to have a unique identifier for every resource, you need to also know what scheme does it come from. Is it a DOI? Is it an ARC? Is it an ISNI? Is it an IGSN? And then finally, some of the issues that have become evident in the modeling work we've done recently is, first of all, we ought to get IGSN into that controlled vocabulary. So it's the one identifier scheme that's missing in the DataCite kernel. I think it would be pretty straightforward to get it in there. We're going to need, to publish samples as linked data, we're going to need canonical URIs for every sample. And I'm suggesting that they might look something like data.igsn.org/ID/ and then the IGSN. And then finally, we'd of course like to use controlled vocabulary terms wherever possible for properties like tectonic setting and stratigraphic unit. But we can only do that if vocabulary terms have stable URIs on the web, ideally as RDF, using the OWL language. So one of the things I'll be advocating for at the workshop in 2 weeks is that IGSN-EV publishes at least some subset of common vocabularies online in the IGSN.org namespace where every term has a URI. Because if we do that, then a project like GeoLink can start using those vocabulary terms right away. And that's what I have. Thank you.
Great, thank you, Bob. Does anybody have any pressing questions for Bob?
Doug, Phils, and I will both be at the workshop in 2 weeks, so we can certainly take more questions there.
Great. And there will be time at the end of this webinar as well. So I think we will move on to Simon Cox, who will talk about the O&M Specimen Model. So I will now pass the ball to him. Sorry for the delay. The list of participants is very long, so it's hard to pass the ball. Here we go, Simon.
I'm now the presenter.
Getting new people on.
Great, yes. Yes, so now you need to go to Quick Start at the top. There's a tab, and then Share Application.
Share screen.
Yes.
Okay.
Great, we are now seeing your screen.
Now, I'm a bit confused. This one, wrong one, huh? Let me see if I can. Still the wrong one. Oh well.
Click on Display Settings up there at the top of the PowerPoint. Go back to your PowerPoint.
Go back to my PowerPoint.
And go into Show. Okay, now see Display Settings, and then swap.
Are we there?
Yay.
Yay.
Thank you very much. Sorry for that, folks. A little bit of patience there. Okay. I hope you can all hear me clearly. I'm going to go back to start out by a little bit of history here, I guess. I'm going to show a couple of pictures from an ISO and OGC standard, which I was largely responsible for developing, which proposed a rather general model for the features associated with sampling in order to do observations. And this is a little bit of UML to start. This diagram shows the core sampling feature model from that thing that's cited at the bottom of the page there. And the idea there is that we have, this is sort of part 2 of a standard which is called Observations and Measurements, that almost all observations, in fact, are, the goal of which is to determine the values of properties of features, that the features which the observations are done on various kinds of sampling features. Now, the kind of samples that IGSN is about is just one kind of sampling feature. There's all kinds of other sampling features, particularly the kind of geometric ones like points and traverses and transects and flight lines and cruises and that. But obviously for the purposes of today, what we're mostly interested in is this part of the model. So in this model, and this is as published in the ISO standard, a specimen is a specialization of a sampling feature. So I've got the two models shown up simultaneously on the screen here at the moment. Generic sampling features have a, can you see my mouse pointer here? Is that showing up?
Yes.
Yes, it is. Good. Okay. So a sampling feature has an intention to sample a feature, something in the world, and so typically the kind of samples that we're talking about in IGSN are collected in order to characterize some geologic unit, for example. And the other key thing about sampling features is they typically occur as parts of complexes. And so a sampling feature might be a drill core, and within that drill core we will have a number of identified specimens taken from various positions along that drill core. So the specimen is a kind of and these things occur together and have relationships and roles between those relationships. So this was the generic model for specimen from the ISO standard. And you can see there's, in addition to the properties inherited from the generic sampling feature, there's a series of relatively generic properties which would apply to all kinds of specimens, not just geological ones. Draw your attention to some of the key properties here, which were the sampling method, the method by which the specimen was obtained from the world, the location at which it was obtained, the time at which the specimen was taken from the world, the current location where it's stored and what shelf or what bag or whatever, a material class that would be rock, leaves, whatever, aqueous samples. In the ISO standard, we also had the notion that there would be a sequence of preparation steps, each of which uses a process, involves an operator, and happens at a particular time. And so a concern of this model was to somehow capture the notion that a specimen typically goes through a sequence of preparation. Well, this, as I say, was the model as it was published in 2011. Relatively recently, actually this is work that's been underway for about a year. Originally we did picking up on the introduction that Bob gave in the previous talk, modernizing from here. Oh, I should say that the sampling feature, observations, measurements, and specimen model was published as an XML schema through Open Geospatial Consortium, a thing called OMXML, but we've most recently been looking at turning that into an ontology. And this is the current, very similar, in fact, to that previous diagram. This is the ontology as described in that paper submitted to Semantic Web Journal, which is cited at the bottom there. You see that much the same properties there. This is a sort of a UML view of an ontology, which is provided conveniently by the RDF editor TopBraid. And most of the same properties of the previous model are presented there, but crucially, we re-examined that part which I finished on talking about before, which was about the specimen preparation process and the sequence of events, because when we tried in practice to apply that, we found some issues, in particular in relation to the way in which one specimen is related to its parents and that kind of sequence. And so we resolved that actually by introducing another ontology called the PROV ontology, which basically seemed to satisfy the requirements. So rather than go and reinvent something and try and remodel this, when we suspect we would have just ended up reinventing the PROV ontology, we said, look, as well as specimens being a kind of sampling feature, and let's propose that they are a kind of PROV entity. Now, for those people who aren't familiar with PROV, I know there'll be a few people on this call who'd be familiar with it, but this is the core PROV model, and there's essentially three classes in the core: entities, activities, and agents. And the basic notion of PROV is that an entity is a thing. Most PROV applications, an entity is in fact some data or a report or a paper, but we're proposing that an entity can also be something in the world which is transformed by a series of activities under the agency of an agent. And there's a set of sort of generic properties giving all the different relationships that might appear between entities, activities, and agents shown in this diagram here. This is an ontology which is published through the W3C, was developed as a kind of rationalization of some previous models like an open provenance model and proof markup language or proof model language. I'm not sure what PML actually stands for, and was published by W3C 3 or 4 years ago now. So the idea there is if we think of specimens, geological specimens, the kind that IGSN is interested in, not just geological, any specimen used in science as being one of these entities, and you can have was derived by relationships to describe the way in which one entity is transformed to get another one under the influence of a bunch of activities. Now, recently we've, and in the context of the SAM light model, which I showed on the previous slide, so SAM specimen is a subclass of PROV entity, and the process by which specimens are transformed would be a subclass of agent. That's an interesting bit of the model which we could probably beyond the scope of this introduction here. Now, just to give a bit of evidence as to how PROV works and why it seems to work, here's an example of a specimen preparation chain taken from a paper that myself and Nick Carr recently submitted to the upcoming ModSim conference in Australia later in this year. And this describes a whole specimen preparation and observation trace. There's a lot of boxes on this, but basically up the right-hand side here, there is a series of specimens gradually getting transformed, and ultimately at the top here we've got a couple of reports from those, and in this middle row of square boxes here you've got the activities which cause the transformations from one to the next, and the agents which are involved in those, and the agents can be things like hammers, saws, mills and sieves. Also the geologists, lab technicians and such like that might be doing this, and you can basically see there's a trace back from the final analysis through from the final report through the analysis, which operated on a particular size fraction sieved from some pulp, which was ground a result of grinding, from some split, from some field specimen which was retrieved from some geologic unit. In principle, all of these things will have separate identifiers, and those identifiers will be URIs. The ones with the dotted outlines here, we would say would not necessarily be of sufficient interest to be reported publicly, but nevertheless they exist at least notionally, and so have identifiers, and for traceability you would recognize that. So that's a sort of an alignment between the kind of specimen preparations sampling model that originated in the ISO standard and then coming through the ontologies and aligning it with PROV. You have these kinds of activities involved in this trace here. There's other notional alignments and extensions that you might have for other parts of the kind of preparation and observation processes that might be involved in geological and natural science samples. Obviously, there's no way I'm going to go through the detail here, but you can sort of see the words that make sense there, including splitting and field sampling and such like. And basically, we've got a proposal here for how they all become subclasses of the PROV model. The final bit of alignment we've been doing is with the biological collections ontology, and this is the most recent piece of work, such that it's far from complete. The biological collections ontology comes out of the biodiversity community, and this is the core of that. It was published in PLOS 1 last year, I think. And the key thing here is in the middle here. It's based on the basic formal ontology (BFO), which sort of comes out of the biomedical community, and has a fundamental split in the world between entities and processes. That's continuance and occurrence. And material samples are a kind of material entity, and we've basically gone ahead and proposed an alignment of all the way down through to specimen and the various processes involved in specimen preparation So we've got a link here up through BCO to BFO. And I'd say I was on a call this morning. It's late now here. It's 11:30 at night. I was at 7 o'clock this morning. I was on the phone with Ramona Walls, Matt Jones, Bob Goralnik. Mark wasn't there. Pierluigi wasn't there this morning, but working on the O&M, OBOE, BCO, BFO alignment. So I'll just say coming soon. Thank you very much.
Thank you, Simon. Does anybody have any questions they would like to ask right now?
Sorry, I was a little more than 10 minutes.
No, that was perfect. Thank you.
I think it's a good point to move to the last one, because then we're getting into the bio world a bit more.
All right. Well, thank you, Simon. I will now pass the ball to John Wieczorek, who will be speaking about Darwin Core for biodiversity samples.
Are you able to see my screen yet?
We are seeing a nice picture.
In my attempt.
Yeah.
Half dome.
Yeah.
Can you see that?
Yes.
Okay. First of all, I've added a few notes on the notes section of the webinar as references to some of what I'm going to show, because I don't have a presentation per se. I'm going to work from material that's published elsewhere, mostly on websites. So Simon's introduction with the biological collections ontology is a good one to give a bit of context. I'll go a step earlier than that and into the Darwin Core. The diagram that's on the screen, if you can see it, can everyone see a diagram on the screen about Darwin Core?
Yes.
Okay, good. This is from a figure in the paper in PLOS One introducing the Darwin Core, and tries to show some of the context of the community for which it was built and some of its origins. It had its, as a standard, it had its origins based on the Dublin Core and how those terms were managed. And so a lot of how Darwin Core looks is very Dublin Core-ish. But it is intended to define metadata terms more specifically in the biodiversity domain. And in the diagram, you can see that its core precepts surround locations, organisms, geological contexts, and taxa. And more recently, we have introduced the specific concept of the material sample, as we find that as we go forward and we get more sophisticated about sharing biodiversity data, we need to understand the provenance and relationships of various samples to each other and to organisms and places from which they came. The Darwin Core is a standard managed under the Biodiversity Information Standards, otherwise known to many as TDWG or TDWG or TDWG, or everybody has their own way of saying it, which started out as the Taxonomic Databases Working Group. So Biodiversity Information Standards is the standards body today. That's its name. It's specifically for biodiversity information, as you can see in the context of the figure that I've shown here. And fundamentally, the Darwin Core is simply a set of metadata terms and their definitions without constraints. There are no constraints, no profiles that are enforced for the Darwin Core as a standard itself. I'll switch now to the quick reference guide for Darwin Core to give you an idea of some of its content. It's quite broad and verbose in terms of the terms that are managed under this standard. I'll make that a little bit bigger for this context. we have various classes of information under which we have Darwin Core terms. The classes are not particularly functional in terms of semantics. They are organizational in terms of understanding what the terms are meant to be associated with in the Darwin Core. We have the concept of an occurrence, which is putting an organism in a place and time. We have an organism. We have then various kinds of material samples. A generic material sample, living specimens, preserved specimens, and fossil specimens. And I won't go into the rest of the detail of Darwin Core, but rather focus on the idea of these material samples, as that's most relevant to what we're going to be talking about in Los Angeles. So the core problem that Darwin Core attempts to solve is the mobilization of biodiversity data from its grassroots, which tends at its least common denominator to be in Excel spreadsheets. As we try to share, a lot of interesting issues arise in terms of standardization. Darwin Core is meant to facilitate that sharing, that data sharing, by defining terms of interest that we have in common. And hopefully then people, when they share, can populate those terms with the same meaning for the values that are contained in them. So that's fairly straightforward. Like he says, that given that 90% of his life is spent on helping people to do this simple task. The issue that arises, and the one that's important to our participation in Los Angeles, is the concept of the identifiers. So throughout Darwin Core, we have various kinds of identifiers. Identifiers for institutions, for occurrences, for organisms, and for material samples, among others. The issue is that given the grassroots origins in Excel spreadsheets in collections, the concept of global unique identifiers hasn't made its way into the psyche of the collection manager. There's no value proposition working inside of a collection to managing yet another number that has no meaning or no immediate meaning, no immediately perceived value. And yet we find as we try to integrate and do interesting things like cite specimens and relate them to other things, that without these global, unique, and persistent identifiers, there's less that we can do. So as we expand into the new realm, the hope is that we will be able to convince folks closer to the grassroots of the value of maintaining global unique identifiers. And given the apparent uptake of IGSNs in the geological community, we would like to see if we could manage to do the same thing with IGSNs or with something very similar and overcome what has been an obstacle, a strong obstacle in the last 10 years of trying to find an identifier scheme and identifier services that people can really buy into and get on board with. The idea then of an IGSN has a lot of appeal in that it has the feeling of something you can trust, confide in, and that will last. And so our hope is, I think, in attending, Rob Grolnick and I, our hope in attending here is to find a way to get our biodiversity community to really buy into the idea of global unique identifiers in order to make that transition from the grassroots in the collection to the semantic web and sharing things and integrating things truly across our domain and across others. So that is a bit of a background of why we're coming to the table here.
Thank you very much, John. So now, I guess this is, we have about 10 minutes or so. If anybody has any questions or has a discussion point to bring up, we'd be happy to hear it.
And I think if anybody comes up with questions after this webinar or any, suggestions, ideas, comments that might help discussions at the workshop, please just send them to us, to Megan or me, and we'll compile that with the documents for the workshop.
Certainly, and I also received a request to make the individual presentations available so that they can be studied. So I will find a place to put those as well as the recording of this webinar.
Yeah, I wanted to thank all the speakers. I mean, this is a really important foundation for the discussions that we will have, and I'm actually really excited about how these various efforts will sort of sit at the same table, and hopefully we will be able to merge the various approaches and also extend what the IGSN has achieved so far into the biodiversity world. I mean, that would be really terrific to have some alignment of efforts, or maybe even integration, because we're increasingly being challenged by sample registrations in IGSN that are more on the biological side than on the geological side, and we need to find ways to better integrate and make it a useful scheme for the physical samples, no matter if they are a rock or a fossil or a living creature. So with that, I shut up and let others talk. Sorry.
Oh, someone's calling into the call.
I'm a woman sitting next to the phone. Well, look, at the moment.
I'm sorry, just one short technical question. Do we have a mailing list, or are we using the list of addresses, emails in the invitation? How are we going to communicate in the run-up to the workshop?
Yeah, so right now it's currently a hodgepodge of a couple different listservs and individual names. We can certainly look into getting a mailing list for all these people if you think that's what we need.
Well, we have a mailing list in the IGSN system that is, I mean, we have several mailing lists there, one just being limited to the members of the organization, and others are more discussion forums, and we should be making sure that everybody, that we get to this list sort of the instructions how to join the more general IGSN group, group discussion or forum or whatever we want to call it.
I'll paste the instructions for that in the email that tells you where the webinar and the presentations are.
Okay. So at the moment, I don't see anybody having comments or suggestions or questions. Again, if those come to your mind after we finish this webinar, then please send them to us, and also stay involved in the activities. As I mentioned, we definitely want to set up a webinar that is going to report on the outcomes of the workshop because participation was limited due to resource limitations. So with that, I just wanted to thank the speakers again. This was really useful, I think, to summarize what's going on in the different initiatives and projects related to physical samples. So I hope to also report on this webinar a bit and bring these various efforts into our session at the upcoming Research Data Alliance plenary in Paris. We have a breakout session there on physical samples. And that's another opportunity to further discuss. So if you are at RDA, I encourage you to participate in that session. Again, thank you everybody for attending. Special thanks to the speakers. And I see some of you in LA in 2 weeks.
Kirsten, which days is the meeting in LA?
Tuesday and Wednesday, September 15th and 16th.
Okay, because I'll be in the UK, but I wonder if there'll be any remote joining arranged.
At this point, we hadn't been set up for that.
Hadn't expected that. Okay.
I mean, we can, you know, if we do end up in a setting where the remote connection will be possible, at least for listening in and you know, communicating on the chat, then I will definitely send out a notification to this mailing list. We are at a hotel, so, you know, the internet, I mean, connectivity may be limited, and we've just had so many bad experiences with that we didn't want to commit to making this sort of virtual and physical workshop. But we'll try whatever we can to, at least for certain sessions, come in. But yeah, I apologize that you know, we hadn't looked out for the overlap with the OGC meeting in the UK. I think it is, right?
Yes, it is.
So hopefully you're going to be at RDA.
I will be at RDA, Kirsten. I'll see you there.
Okay, awesome. All right. Was there another comment from somebody? I heard something.
I'm not sure if that was just noise.
Okay. All right. Thanks again, everybody, and have a great day.
Thanks.
Very much.
Great night for those of you.
All right.
Right.
Thanks a lot, Kirsten.
Okay.
Off to bed.
Good night.
Take care.
Good day and good night.